Hey guys, tonight we drift outward into the endless dark, to follow something subtle but strange. A faint tug, a hidden lean in the structure of the cosmos. You float just outside time now, beyond the sunlit planets and the radio static of Earth. Around you the stars smear into velvet. It's quiet and it should feel directionless. But it doesn't. There's a pull, not gravity, not momentum, not even time. Something less obvious but just as real. You've never thought of the universe having a direction. After all, space is supposed to be isotropic. Every textbook says it: no up, no down, no cosmic left or right. Just boundless symmetry like a perfectly shuffled deck of stars. But tonight that ideal begins to flicker. You'll see clues in the ancient light left over from the Big Bang. You'll feel the flow of time and wonder why it only goes one way. You'll stare into galaxy maps and spot alignments no one can explain. And by the end, you might ask something that should terrify you. What if the universe has a front and back a true up? So, before we drift too far into the void, take a moment to like the video and subscribe, but only if you genuinely enjoy cosmic storytelling like this. And, as always, let me know where you're watching from and what time it is in your corner of the universe. Now, dim the lights, breathe deeply, and let's begin tonight's descent into the unknown. You are floating far beyond the planets now. Space stretches forever smooth and calm, but you feel it the barest pressure like you're leaning forward into a slow, invisible current. It's not strong, but it's consistent. Imagine a vast ocean with no waves, just one unending tide moving beneath the surface. That's what you're feeling. That's the arrow in the dark. We usually assume space is directionless. It's not just a comforting idea, it's foundational to modern physics. Cosmological principle, they call it the universe on large scales, looks the same in every direction. No preferred axis, no special location. But assumptions are dangerous in space. The first signs came from the cosmic microwave background, CMB for short. It's the oldest light in the universe released when the cosmos was just 380,000 years old. When we first mapped the CMB in detail, it looked exactly as expected, random, tiny temperature fluctuations scattered across the sky. Almost perfectly uniform. Almost. Because then we noticed something. A strange alignment. Not just noise, not just randomness. It looked as if several low-frequency temperature patterns, the largest ripples in the sky, were pointing in roughly the same direction. A direction in space, like an arrow drawn across the sky. They called it the axis of evil, not because it's actually malevolent, but because it breaks something sacred symmetry. The idea that no part of the universe is special, that all directions are created equal, and, if that breaks, what else goes with it? Mainstream cosmology still debates whether the axis is real or an observational illusion. Maybe it's a statistical fluke. Maybe it's dust in our instruments. But here's the part: you can't shake the same alignment shows up in multiple surveys. In temperature maps. In polarization. In galaxy clusters. Physicists still argue whether it's real or just cosmic coincidence amplified by our pattern-seeking brains. But tonight, as you drift in this directionless ocean, you feel the faintest current brushing against your skin. Something ancient. Something large. If the universe truly has a preferred direction, then every journey, every orbit, every expansion may be happening along a slant we never realized. And that slant, quiet, steady, older than stars, might be pointing to something, or away from it. Just like a compass that doesn't spin wildly, but always settles toward one unknowable true north. It's like the universe whispered, "You're not adrift. You're drifting somewhere. You move deeper into the quiet. Stars recede behind you, shrinking into dust, and yet still you feel it not a pull, not motion, but orientation, like the air has turned and you are facing something. You remember the early maps, the CMB, the axis of evil, but that was just the beginning. The more we looked, the more alignments we found. Different surveys, different data, and they all seemed to whisper the same thing. Something is wrong with random. Consider quasars, enormous, ancient, distant engines of light powered by black holes so large they outshine entire galaxies. They should be scattered in every direction, their polarizations totally uncorrelated. After all, the distances between them are so vast that they could never have influenced each other. And yet, in 2014, scientists studying quasar polarization noticed something impossible. Across billions of light years, these distant beacons seem to align not perfectly, but strangely statistically, uncannily like iron filings, twitching along some invisible cosmic field. The alignment stretched over 4 billion parsecs. That's not just big. That's bigger than should be possible under the standard model of cosmology. Physicists called it the Large Quasar Group Alignment, and while not everyone agreed on its significance, the implications were unsettling. Either some vast-scale structure exists that we don't understand, or our basic ideas about randomness, space, and causality are incomplete. Again, symmetry cracked. One mainstream fact remains: the universe is expanding, and that expansion is accelerating. Dark energy seems to push everything outward in all directions. But here's the twist: dark flow. Dark flow is a name for something we can't explain. In the 2000s, galaxy clusters were found moving toward a specific region of the sky fast. Much faster than expected. They weren't just riding along the universal expansion, they were drifting toward something beyond the observable edge. It was as if some great attractor outside the known universe was pulling them in. A gravity without source, a motion without reason, a direction without origin. We tried mapping it, measuring it, questioning it, and though subsequent studies debated the results, some claiming the flow faded, others insisting it held something stuck in our minds. What if space isn't expanding evenly? What if somewhere beyond the curtain there's structure pulling strings? Fringe theories emerged, bubble universes colliding with ours or scars from a pre-Big Bang epoch. One hypothesis even imagined our universe as part of a larger multiversal foam, colliding, shifting, drifting. And maybe, just maybe, this flow was the trace of another universe brushing against ours. Physicists still wonder whether dark flow is real or whether we've been fooled by our own instruments. But you float here in silence and you can almost feel it. A tide, a whisper, a lean. Even in quantum fields, even in gravitational waves, some physicists suspect anisotropies, slight irregularities that hint at direction, at orientation, at a flaw in the mirror of the cosmos. And all this raises a terrible, beautiful question. What if there is a forward in the universe? What if we're all passengers tilting toward some unseen terminal? The silence grows deeper. The galaxies blur together now. Your frame of reference evaporates, but the direction remains. And it begins to feel less like a path and more like a memory, as if the universe remembers which way it was born. You pass another curtain. It's not real, but it feels like one. As though somewhere in the deep fog of intergalactic dust you've crossed a threshold, and now the light changes. You look behind you. It's all still there. The CMB, the quasar, trails the trembling of dark flow. But ahead, it grows stranger. Now you're thinking about the dipole. In cosmology, the dipole refers to a measurable anisotropy in the cosmic microwave background, the faint afterglow of the Big Bang. It's the first whisper we heard that said not everything is symmetrical. From Earth, the CMB appears just slightly hotter in one direction and slightly colder in the opposite. That's because we're moving through the universe. The Doppler effect makes the microwave background look squished in front of us, stretched behind. Fair enough. That's motion. That's expected. But then the radio dipole came along, and things got muddy. In the 2010s, researchers began measuring the distribution of distant radio galaxies. Billions of data points, each one whispering a position, a brightness, a direction. And when they plotted the results, they found a strange preference. More galaxies appeared in one half of the sky than the other. The direction matched the CMB dipole. That was suspicious. But here's the twist: the asymmetry in radio sources was stronger than what the CMB dipole alone could explain. Much stronger. Almost as if the universe wasn't just biased from our movement, but biased in itself. One mainstream explanation was observer error. Maybe telescopes just aren't perfectly calibrated. But the findings held up across surveys. Not all scientists agreed, but those who took it seriously began asking, what if the CMB isn't just Doppler shift? What if we're seeing a genuine imprint of large-scale anisotropy? If that's true, the implications are staggering. It would mean the very oldest light we can observe carries a fingerprint from something before the universe was smooth. That fingerprint wouldn't be noise, it would be direction. An arrow embedded in the fabric of everything. The radio dipole isn't alone. Galaxy spin directions have also raised eyebrows. Astronomers have mapped out spiral galaxies and tried to catalog their spin orientations clockwise or counterclockwise relative to Earth's vantage. In a perfectly random universe, there should be no preference. But several studies, not without controversy, have claimed to detect a mild statistical preference for one spin over the other, depending on which part of the sky you're looking at. One might expect noise. But this is something else, a cosmic chirality. Left-handedness, right-handedness, the mirror cracking again. Still, physicists argue. Is this a fluke of small data, a trick of perspective, or something deeper, something that violates one of the most sacred assumptions of cosmology, isotropy? The idea that every direction in the universe is fundamentally the same. You've believed this your whole life. It's the bedrock of standard cosmology. And now it whispers, what if not, some fringe theories have tried to interpret these directional asymmetries through strange frameworks like anisotropic inflation. Imagine that when the universe was just a split second old, the inflationary expansion wasn't perfectly even. Maybe quantum fluctuations favored one axis. Maybe space inflated a little faster this way than that way. If that happened, we'd still be feeling the ripple now. We'd still be drifting through a lopsided balloon. Others point to relic gravitational waves, primordial echoes that ripple differently depending on the direction of space itself. Or even more radically, that space-time is not a continuous field, but a lattice, a structured fabric with preferred orientations built into its deepest weave, like wood grain, like the brush strokes of some ancient painter. Physicists still debate these things late into the night, staring at whiteboards like prophets reading bone fragments. And you, floating in the quiet, feel the grain too. Everything wants to go that way. The stars behind you dim, and your path begins to tilt. You don't feel it at first because in space there's no up. But slowly, as galaxies pass like embers, the drift becomes undeniable. It's not just your imagination. The whole universe seems to be leaning, ever so slightly, in one direction. Scientists call it the dark flow. In 2008, a team analyzing the motion of galaxy clusters' massive islands of matter tethered to nothing noticed something odd. Using the kinematic Sunyaev-Zeldovich effect, they tracked subtle shifts in the CMB as these clusters moved through space. The result, hundreds of galaxy clusters appeared to be streaming in the same direction, across billions of light-years at speeds up to 1,000 km/s, toward something. That something lies beyond the observable universe. Now pause with that thought. The observable universe is already mind-breaking. It's the bubble of space from which light has had time to reach us since the Big Bang, about 93 billion light-years wide. Beyond that, no one knows. Yet the dark flow suggests that something beyond that edge has enough gravitational pull to affect our entire visible cosmos. That's not supposed to happen. Cosmic inflation should have wiped out any influence from beyond. But the data wouldn't shut up. Some theorists proposed super-horizon structures, objects so massive and so ancient that they predate our observable slice. Perhaps gargantuan clusters remnants from a previous cosmic cycle, or the shadow of another universe brushing against our own. Others whispered bolder ideas. What if the dark flow is evidence of a multiverse A, higher dimensional landscape, where other universes bubble and collide, and the scar of one such collision is tugging our own cosmic raft toward it, like two raindrops merging on a windshield, leaving streaks of tension across their surfaces. Or maybe it's a tear, a breach in space-time, a rip in the expansion letting gravity from outside bleed in. But as always, the data resisted clarity. Later, measurements questioned the strength of the signal. Some surveys found less dramatic motion, others found none. Still, the idea lingered, because it asked the one question no cosmologist likes to answer. What's beyond the edge? If there is a preferred direction, and if that direction is being pulled, then we're no longer just passive observers of a uniform expansion. We're on a ship. Drifting not aimlessly, but toward something vast and unknowable lurking beyond the cosmic horizon. A cosmic river guiding us not because we see it, but because we can't look away. Even in the most grounded models, the notion of a universal axis, the axis of evil, some have called it, keeps appearing. It aligns the CMB quadrupole and octupole moments. It shows up in large-scale structures. It's even been linked speculatively to the dark flow's vector. Coincidence pattern. Or just our minds trying to impose meaning on chaos, physicists still argue whether the dark flow is real or just an artifact of limited data. But if it's real, then it rewrites everything. It means the universe has an external context, a stage beyond the stage, a pull from outside the play. And you're just a passenger on this current gliding deeper into the quiet, toward whatever waits on the other side of infinity. As you drift, you think of salmon in the dark, moving upstream, guided by something they've never seen. The universe, too, might be swimming toward its unknown spawning grounds. One final note of dry cosmic comedy, if the dark flow exists, we'll never catch it. We're moving with it, trapped in its pull, always following, never arriving, unless we already have. The clock of the universe ticks strangely here. You remember what time is supposed to feel like steady metronomic indifferent. But in the deep dark it begins to stretch, twist. Sometimes it folds in on itself. And as you drift farther into this strange directional pull, you begin to wonder if time itself shares the same preference. Could the universe's arrow of time be aligned with its arrow of space? It sounds absurd at first. Time and space are different beasts intertwined, sure, but fundamentally distinct. Time has an arrow. Space, supposedly, does not. Yet there's an itch that won't go away. What if they both lean the same way? In classical physics, time's arrow comes from entropy. Things decay. They spread out. Ice melts, stars die, people grow old. Entropy increases, and the forward direction of time is simply the direction in which disorder grows. But in cosmology, it's not that simple. The early universe was incredibly ordered low entropy despite being a chaotic soup of plasma. It should have been messy. Instead, it was smooth. And then something strange, gravity. Gravity clumps things. It reverses entropy's script. It pulls particles together, forms stars, builds galaxies. It creates structure. And in doing so, it becomes the engine that breaks the cosmic symmetry between future and past. One compelling idea that the Big Bang wasn't the beginning but the middle. There may be another side, a mirror universe moving backward in time as we move forward. In this model, known as the Janus cosmological model, after the two-faced Roman god, the universe expands in both temporal directions from a shared origin point. From the Big Bang outward, us and our opposite. Their entropy increases toward their future, which is our past. You are one half of a cosmic palindrome. And now it gets stranger. Some physicists speculate that this mirror universe, if it exists, could explain the asymmetries we detect the CMB's lopsidedness, the alignment of large-scale structures, even dark matter. Because if there's a time-reflected cosmos entangled with our own, then its gravitational footprint might bleed into our universe, subtly warping what we observe. And if that mirror universe shares a spatial alignment, if its entropy gradient flows in parallel with our own directional biases, then we are not simply drifting toward a gravitational attractor. We are drifting toward our reflection. Imagine a fogged-up bathroom mirror. You wipe a line down the middle. On one side, your face. On the other, a backward smile blinking in reverse. That's the universe, perhaps. A single face split by time, exhaling into both futures. And you, as you drift, are moving closer to the seam. Physicists still argue whether time has any true direction at all. In many equations, it doesn't matter forward or backward the math works, but reality disagrees. Eggs don't unscramble. You don't unage. And light doesn't untravel. Unless time itself is emergent. Some fringe theories propose that time is not fundamental, but a consequence of entanglement. That the flow of moments we feel is a shadow cast by quantum correlations across space. If so, then time, like space, can have orientation. And maybe, just maybe, the universe's so-called preferred direction is not just where we're going, but when. Here's a final metaphor just to twist the knife. Imagine the universe as a great spiral seashell spinning silently in multi-dimensional space. You are a fleck of foam spiraling outward from its core, but the curve isn't random. It arcs towards something. It leans, time and space swirling together like water down a drain. Except the drain might be forward, or backward, or both. You meet the axis. It has no name, not really. Scientists have a few, some call it the axis of evil, half joking, half dreading. Others just call it the alignment because it's too eerie to name outright. This is the moment where your descent into cosmic lopsidedness turns tangible. You're not just talking about a direction anymore, you're staring right into it. It began, innocently enough, with a map. In 2003, the Wilkinson Microwave Anisotropy Probe WMAP revealed something strange in the oldest light of the universe, the cosmic microwave background. This was the afterglow of the Big Bang, a perfect snapshot of the infant cosmos when it was just 380,000 years old. It should have been random, smooth, no preferred direction, just temperature fluctuations scattered like static on an untuned radio. But it wasn't. A peculiar alignment appeared in the data large-scale temperature anomalies that seemed to line up along a specific axis in the sky. The quadrupole and octupole patterns, those are just names for the shapes of the fluctuations, were pointing the same way. It was as if the universe had a spin, as if everything was stretched in one weirdly consistent direction. Then came Planck. A different satellite, better resolution, more data, and the alignment didn't go away. If anything, it looked sharper, more undeniable. Now, the question wasn't if the universe had a preferred direction. It was why. Here's the twist that makes physicists shift uncomfortably in their chairs: this axis. It lines up suspiciously close to the plane of the Earth's orbit, which should not happen, because the universe is not supposed to care where you are, where Earth is, or how you're looking at it. This principle, called cosmological isotropy, is bedrock. The universe should look the same in all directions. No special axis, no special observer. And yet, here you are, floating toward something that shouldn't be there, something that might be watching back. Some say it's just a coincidence, a fluke of data processing, maybe even a statistical illusion caused by galactic dust or the Milky Way's foreground glow. But others aren't so sure, because this alignment isn't alone. Other cosmic structures, like the spin directions of distant galaxies or the large-scale flows of galaxy clusters, also appear to align with this strange axis, almost as if the entire universe is rotating around a spine you can't quite see. You remember being told space has no up or down, that direction is meaningless beyond Earth. But now you're not so sure. Maybe there is an up, a cosmic north. And maybe we're tilted just slightly wrong. There's a deep discomfort here, a subtle violation of principle. Because if the universe has an axis, it means we can orient ourselves in space, which means space might not be the uniform backdrop we thought it was. It could have seams, biases, edges. Physicists still argue whether this axis is real or artifact. Some want to believe it's a glitch. Others think it hints at new physics, maybe remnants of pre-Big Bang conditions, or anisotropic inflation, or something stranger still. There are fringe theories, of course. Some claim this alignment is the fingerprint of a rotating universe, that all of space-time is slowly turning like a vast hurricane of matter and energy. Others believe the axis points toward a gravitational attractor, so massive, so distant we can't yet measure it. A great void beyond the observable edge, tugging the cosmos into alignment. And a few whispered darker ideas. That the alignment is not physical, but informational. That it reflects the limits of perception, or even the structure of consciousness itself. But here's the simplest possibility, the one you keep circling back to like a moon to its planet. The universe may be telling you something, a gentle nudge, a soft gravitational pull, a tilt in the cosmic floorboards that says this way. And as you follow the axis deeper, you can't help but feel like you're heading toward a center that shouldn't exist. A line etched across the sky. Not a scar, not a beacon. Just a subtle indication that all is not symmetrical, not balanced, not safe. You begin to wonder, is this a trail or a boundary? And what happens if you cross it? You cross it. Not literally, there's no line, no warning, no toll gate at the edge of the axis. But something shifts as you let yourself fall further into its implications. A tilt not of space but of assumptions. You are told that the cosmos is smooth, that it expands evenly in all directions like a balloon inflating in an empty room. No up, no down, no center, no edge. But now, riding this invisible filament through the cosmos, you begin to see hints of an asymmetry that could rewrite that picture entirely. Let's go further back than light can travel. In the earliest moments of the universe, a burst of incomprehensible expansion inflation stretched space-time itself by orders of magnitude. Quantum ripples were inflated into galaxy-seeding density fluctuations. That's the story we know. But what if inflation wasn't even? Some models suggest the inflated field, the hypothetical engine of inflation, could have had direction-dependent properties. Maybe it was tilted. Maybe it expanded just a little faster in one dimension than another. That tiny lopsidedness could have snowballed across billions of years, leaving behind a universe with a bias and ancient momentum baked into space-time itself. In this view, the axis you're following isn't something added later, it's primordial. A birthmark from the universe's first trillionth of a second. One mainstream paper even suggested an exotic idea, anisotropic inflation caused by vector fields. Instead of just scalar fields inflating equally in all directions, vector fields introduce orientation and arrow embedded in the expansion. A cosmic push. Of course, that breaks one of the most sacred assumptions in modern cosmology, that the early universe had no preferred direction. So, naturally, many physicists are skeptical. Still, the data doesn't go away. Even as satellites improve, detectors get more sensitive, and foregrounds are better subtracted, the strange alignment remains. Slightly blurred, slightly contested, but real enough to keep reappearing like a faint note under the louder melody of accepted physics. You look around. The cosmic structure's walls of galaxies, voids, filaments stretch across billions of light years. They form a web-like pattern, but some of them seem too aligned, almost like threads pulled taut along the same ghostly line. There are even statistical hints that galaxies' spins in opposite parts of the sky prefer one orientation over another. Now, if you're thinking, but that's impossible, good. That's what scientists said too. In fact, a 2020 study looking at thousands of spiral galaxies noticed that their handedness, whether they twist clockwise or counterclockwise, wasn't random. It followed a pattern across large scales, a sort of chirality of the cosmos. This shouldn't be. The large-scale universe should have no twist, no swirl, and certainly not a directional bias, unless of course it does. And the most eerie part. Some of these galactic spin alignments also line up roughly with that same old CMB axis. Coincidence, systematic bias in telescopes. A pattern-seeking brain playing tricks. Or something deeper. Physicists still debate it. Some call it pseudoscience. Others cautiously say anomaly. A few are brave enough to suggest it might be real and indicative of a rotating universe. Yes, that old idea again. You see, it's not totally forbidden. A universe can rotate under general relativity, Kurt Gödel. Yes, that Gödel once proposed such a solution to Einstein's equations. A spinning universe. But it came with problems, like allowing time travel. Closed time-like curves, causality loops. So the idea was largely dismissed as elegant nonsense. Still, if space-time is subtly rotating on a scale far beyond human comprehension, then maybe we'd see just what we see now. A faint axis, a slight anisotropy, a ghost of angular momentum preserved from a time before time had meaning. let's not forget the metaphors here. The axis becomes a cosmic compass, but with no map. A scar from a forgotten collision. Or perhaps a crack, a flaw in the curvature of reality itself. And the further you drift down it, the more you feel like a passenger on something ancient and directional. Like riding an arrow mid-flight knowing neither its origin nor its target. Darkly, you wonder what if the arrow already struck something, and this, our universe, is just the shock wave. You coast in silence now as if space itself is holding its breath. Not because there's nothing here, but because what's here refuses to behave. The whispers of the axis grow louder, not with sound of course, but with tension. Cosmic tension. Like a violin string stretched across the void. And suddenly, the direction isn't the only thing that's weird. Because something else is off the flow. Enter dark flow, a name as poetic as it is unnerving. In 2008, scientists analyzing galaxy clusters using the Sunyaev-Zeldovich effect noticed something strange. These massive clusters, entire cities of galaxies, weren't just expanding outward with the rest of the universe. They were drifting, en masse, toward a single point in the sky, not orbiting something, not falling into a known structure, just drifting like flotsam on an invisible current. And here's the kicker, the direction they were heading. Roughly aligned with the same cosmic axis you've been tracing this whole time. Coincidence? Maybe. Or maybe the axis isn't just a direction. Maybe it's a gradient, a slope. Something that tugs. That initial study suggested these galaxy clusters were moving at 601,000 km/s beyond the pull of anything we know. As if something beyond the observable universe, beyond our light horizon, was exerting a gravitational tug. But what could do that one fringe theory? An enormous supervoid or supermassive structure outside our observable bubble-warping space-time, subtly across billions of light years. Another more radical, a multiversal collision. Imagine our universe as one bubble in a vast foam of universes. Some theories in string cosmology predict such a foam with universes occasionally brushing or bumping into each other like soap bubbles in a sink. If one of those universes collided with ours early on, grazing just enough it could have left a dent, a pull, a preferred direction, an impact scar, visible only in motions we barely understand. But not everyone buys it. The dark flow controversy is far from settled. Later measurements with Planck didn't confirm the original findings, though they didn't entirely disprove them either. The question remains open, and so, like the axis itself, dark flow hovers between real and mirage. But you can't shake the feeling that the universe is leaning, that everything, the galaxies, the voids, even time itself, is canted ever so slightly toward something vast and hidden, like a marble rolling across a nearly flat floor. Poets might say the universe is homesick. Scientists call it anisotropy. You stare out again, and the stars don't look the same anymore. They seem organized. Not in a grid, but in a tide. A migration you were never meant to notice. And that unsettling thought creeps in, what if we're being pulled towards something? Not falling exactly. Just nudged. It's the oldest fear in navigation, the current you can't see. One dry, dark joke you remember from a cosmologist's lecture. If we are drifting into another universe, at least we'll be on time. It lands harder now. Physicists still argue whether dark flow is real, a statistical artifact, or simply misunderstood data. Some claim it's just an illusion caused by unaccounted galactic dust. Others whisper about bulk flows, topological defects, even wormholes. You wonder if the flow is real, what lies at its end. a black hole the size of a universe, a neighboring cosmos colder, older, more hostile, or simply nothing. And isn't nothing the most terrifying destination of all? The axis remains. Not a line on a map, but a suggestion. A gravitational shrug in the fabric of reality. And now that you've felt the flow, you can't unfeel it. It's as if the entire universe is subtly but undeniably going somewhere. And you're just along for the ride. The silence thickens as you press farther deeper, not just into space but into the fabric beneath it. You've followed the axis. You've sensed the flow. And now you encounter something older, stranger. Not a force, not a destination, but a shape. A twist in the cosmic embroidery. Cosmologists call it the dipole anomaly, a dry name for a weird truth the universe might be lopsided. Let's zoom out way out. When scientists map the cosmic microwave background, CMB, the ancient light left over from the Big Bang, they find it isn't perfectly uniform. Sure, it's smooth, impressively so, but not entirely. There's a gradient, a temperature difference between one side of the sky and the other. Just a few parts in 100,000, but it's there. They called it the dipole, and for a while it made sense. Maybe it's just our motion, they said. Our galaxy is moving through space at about 370 km/s relative to the CMB, and this motion blue shifts the light in the direction we're heading. Red shifts it in the opposite direction, like the Doppler effect with sound. Fine. Case closed. Except it wasn't, because this dipole doesn't just show up in the CMB. It echoes in other places. Radio Galaxy surveys quasar distributions, X-ray backgrounds, all show unexpected alignments with that same axis. The dipole direction keeps showing up again and again like a glitch in the cosmic wallpaper. And the twist. When you correct for our motion, the dipole still lingers. It shouldn't, but it does. This suggests the anisotropy isn't just in the background light, it's baked into the large-scale structure of the universe itself. Like a swirl in batter that didn't quite mix. Some physicists whisper of primordial turbulence, as if the early universe was stirred in one direction more than others, an ancient swirl that never settled. Others speculate about topological defects like cosmic strings or textures, leftover scars from phase transitions in the universe's infancy. And then there are those who propose something wilder, that the Big Bang itself wasn't symmetric. That the explosion wasn't truly an explosion, but the unfolding of a higher dimensional membrane, a brain in string theory that tore or rolled in a preferred direction. You're floating inside the consequences of that tear. This isn't just about heat maps or data anomalies. It's about the very architecture of everything space-time matter, being subtly directional. The lopsidedness, the axis, the dark flow, they might all be faces of the same hidden shape. But here's the unease, no one knows why. Physicists still debate whether these patterns are artifacts, errors in calibration, leftover biases in how we collect and process cosmic signals. Maybe it's all an illusion. But if it's real, then the entire cosmological principle, the belief that the universe is homogeneous and isotropic on large scales, may be quietly breaking down. And if that principle breaks, our models of everything begin to tremble. No more everywhere is the same. No more no center. Instead, direction, orientation, cosmic polarity. You turn your head figuratively, of course, and look back. That dipole direction, once a technical quirk, now feels like a compass, a secret arrow stitched into the heavens. And you feel small again. Not in the poetic way, in the disoriented way. Because what happens to a map when you realize north isn't a convention, it's a law. There's a dry line one physicist once offered during a panel. If the universe has a direction, maybe it also has a destination. He chuckled. No one else did, because destinations imply intent, and intent implies something else entirely. You drift through this thought and the silence shifts again, not empty, but pregnant. Something is out there, or in here, or everywhere. A spiral, a current, a memory. And you wonder not for the first time tonight what part of this direction is physical, and what part is just your instinct catching up to the truth. You drift now, not just through space, but through questions sharpened by time. If the universe has a preferred direction, if this axis of asymmetry is real, then a deeper question begins to rise quiet and thunderous all at once. Why? And more hauntingly, what lies along it? You stare into the abyss not with fear, but with a strange intimacy. You've followed this thread from microwave echoes to dark rivers of matter, to the silent tilt in the heavens. And now you arrive at the most unsettling possibility yet. What if the universe is rotating? It sounds absurd, childish even. Space doesn't spin. It stretches, it expands, but it doesn't rotate. Except, what if it does? In 1949, Kurt Gödel, yes, the same Gödel of incompleteness fame, wrote a solution to Einstein's field equations describing a rotating universe, a universe where time itself twisted into a loop, where you could, in theory, circle back and meet yourself before you left. It was dismissed. Too weird. Too unlike what we see. But pieces linger. Rotating universe models called Bianchi models suggest that under certain early conditions the cosmos could have been born spinning, ever so slightly. A whisper of angular momentum woven into the vacuum. Modern observations from WMAP and Planck satellites mostly rule out large-scale rotation. Mostly. But there are wrinkles, tiny anomalies in the cosmic microwave background that don't quite behave as they should. Symmetries that should be random, but aren't. One such wrinkle, the axis of evil you met earlier. It aligns eerily well with what a slow primordial rotation might produce. Physicists still debate whether these hints are real, just dust noise, or software errors. But the pattern lingers. And, deep down, you sense it. If the universe spins, then everything you know about cause and effect past and future becomes negotiable. A rotating universe could permit closed time-like curves. In plain terms, time travel. Not science fiction, just weird math. If the cosmos bends in on itself just right, then maybe somewhere out there, billions of light years away, there's a region where time loops. An eddy in the river of becoming. But more than that, a rotating universe suggests structure beyond randomness. A cosmic inertia. A before and after to the Big Bang itself. Because rotation requires torque. Torque requires a source. So, who spun it? Was it some asymmetry in the quantum foam before time began? Was there another universe nearby brushing past ours, imparting a twist? Or was there no spin at all, just the illusion of it? A topological quirk of how we measure how we perceive direction in a curved space-time. You float now in a thought experiment. A lone speck in a spinning nothingness. If you rotate, how would you know? There are no landmarks, no walls, no background. Only motion relative to what maybe the universe isn't rotating. Maybe you are, but the science won't let it rest. New telescopes, new surveys, new gravitational wave data. They all keep whispering the same thing. There might be a pattern here, and it might be older than light, the unsettling humor. If the universe is spinning, it's doing so at an unimaginably slow rate. one rotation every tens of billions of years, barely detectable, like a sigh stretched across eons. But to something bigger than you, to a god, to a multiversal observer, that rotation would be obvious, felt, measured like heartbeat and breath. You can't help but wonder what else would be obvious to a being large enough to grasp the shape of space-time. And if that being exists, is it looking down that axis now? The spiral continues. You're inside it, part of it, not drifting, but orbiting, not lost, but dancing on a turning stage whose boundaries no one has ever touched. The sky has always whispered stories. You just didn't always know where to listen. Now you tilt your thoughts toward the stars again, not as twinkling ornaments, but as silent participants in a mystery larger than galaxies. If the universe favors a direction, then it must have left fingerprints. And perhaps, just perhaps, those fingerprints live inside the rotation of galaxies. Look at any spiral galaxy from the glowing arms of Andromeda to the swirling haze of NGC 1300, and you'll notice the same thing they spin. But here's where the question begins to spiral too. Do they all spin randomly you would expect them to? After all, in a truly isotropic universe, one without a preferred direction, the rotation of galaxies should be evenly distributed. Left-handed, right-handed, like cosmic coins flipped in silence. But what if they're not? What if there's a pattern? In the early 2000s, a scientist named Michael Longo noticed something strange. He analyzed tens of thousands of spiral galaxies and found a slight bias, more galaxies spun in one direction than the other. Just a fluke, maybe. But the odds of that asymmetry happening by chance? Roughly 1 in 1,000. Others jumped in to check. Citizen scientists, through Galaxy Zoo, helped classify galaxy spin directions, and again, a preference emerged. The kicker. The alignment of this preference lines up eerily with the same axis seen in the cosmic microwave background, the axis of evil again. That invisible thread pulling through deep time. If galaxies across billions of light years are spinning in the same cosmic handedness, then something monumental is at play. Because galaxies don't talk to each other. They don't align out of courtesy. They align because of something older. Some physicists believe the asymmetry is an illusion, that human classification biases or incomplete sky surveys are skewing the data. But others argue this may be a relic of the primordial angular momentum seeded before stars were even atoms. You pause here, thinking not just of science, but of a deeper metaphor. A child spinning a top, watching it wobble, noticing how every top she spins today favors one side. Same direction, same lean. She doesn't know why. But she starts to suspect maybe the surface is slanted. Maybe the table remembers. Could the early universe, just like that table, have held a subtle slant, a directional bias embedded in space-time itself? It's almost funny. For centuries, humans thought Earth was the center of everything. Then Copernicus pushed us aside. Then Hubble moved us farther. Now we look around and wonder, is there a center after all? Not a place, but a spin, a vector, a motion that everything dances to whether it wants to or not. And if that's true, what happens when we extrapolate the axis outward, like a beam shot from deep time through every layer of the universe? Where does it go? Does it intersect with regions of void? Those cosmic deserts where no galaxies live? Does it pierce the great cold spot, that oddly chilly region in the southern sky, with no clear cause? Does it point toward something we've never even imagined? The joke is dry but hard to ignore. If we ever find out where the universe is pointing, What exactly do we plan to do with that information? You won't build a compass. You won't launch a probe. You'll simply sit somewhere on a small planet in an unremarkable solar system, trying to imagine why 1 trillion galaxies all decided in the silence before sound to spin the same way. And if you follow that thread far enough, you might realize you're spinning too. In your atoms, your blood, your thoughts, aligned to something older than the stars. Now you descend deeper, not just into space, but into the geometry of reality itself. You've looked at galaxies spinning like cosmic pinwheels. You've traced microwave echoes whispering of a lopsided birth. You've seen cold spots and strange alignments and all the little clues that point toward a universe with a secret preference. But what if the answer doesn't lie in the universe, but in how it's shaped? The notion seems simple at first. Space is three-dimensional. Add time, and you've got space-time Einstein's playground. But the real shape of the universe, it's not as intuitive as it sounds. Is it flat, curved, finite, or infinite? Mathematicians have a word for the shape of space topology. And some believe that topology might be the key to understanding why the universe appears to have a direction. Not because it's truly pointing somewhere, but because its very geometry creates illusions of directionality. Imagine standing inside a vast hall of mirrors. The room is finite, but reflections stretch in every direction, echoing forever. You spin. Patterns appear. Do they mean something? Or are they just artifacts of the room's shape? Now zoom out. You're inside the universe itself, a cosmic hall of mirrors, but one built from space and time. Some physicists speculate that the universe may have a multiply-connected topology, like a 3D video game map that loops when you walk too far in one direction. In such a world, light from a galaxy might reach you from more than one path. The same object might appear in two directions at once. Patterns repeat, structures align, and suddenly, you begin to see what looks like a preferred direction. But it might not be a direction at all, just a glitch in the cosmic architecture. Of course, this is only one possibility. There's another, and it's weirder. Some theorists have proposed that the universe's shape may not be entirely Euclidean, that is, flat and sensible. Instead, it could be anisotropic, stretching slightly more in one direction than another. Think of a balloon being inflated not uniformly, but with a bias. One side stretches faster. Galaxies drift more in that direction. The cosmic background warps, and we're left with the illusion of a cosmic arrow. Mainstream cosmology tends to reject these ideas, favoring the elegant simplicity of isotropy. But not everyone is convinced. In fact, data from Planck WMAP and earlier probes shows faint signs of large-scale anisotropy, too subtle to call conclusive, but too persistent to dismiss. Physicists still argue whether these signals are noise or prophecy. And that's the haunting part. If the very geometry of space is skewed, if the canvas of the cosmos is pulled in one direction, then everything inside it would inherit that slant. Galaxies, light, time, memory, even your own concept of forward. It becomes strangely poetic. You live in a universe that might be slightly lopsided, like a handmade bowl. The asymmetry, too faint to notice day by day, but unmistakable when you pour in stars and time, and let them swirl for 13 billion years. And here's the dark joke. If the universe does have a shape bias, then every experiment we do, every telescope, every particle detector is already tilted. The measuring stick itself is crooked. So, how do you detect a direction? If your entire reference frame is part of the curve, physicists dream up clever tests. Circular polarization of gravitational waves, subtle shifts in cosmic birefringence, large-scale patterns in the orientation of galaxy clusters. But the truth remains elusive, and so does the center, the edge, the purpose. You look back at the stars, and for a fleeting second you feel like you're standing on the inside of a soap bubble, thin, curved, luminous, and wondering if the bubble itself is breathing. Is that what direction really is? A ripple from the breath of space. A memory from before the first light. You float through that thought like dust in cathedral air, and realize there may never be a map. Not because the universe lacks meaning, but because the meaning is folded into the shape itself. You begin to suspect something. Maybe the universe isn't telling you anything at all. Maybe you're projecting tracing patterns where none exist. But then again, maybe the patterns are real and it's your understanding that isn't big enough yet. Tonight you float through one final possibility more disconcerting than all the rest. What if the universe has a preferred direction? Because time does. At first, it sounds like a category error. Space is one thing, time is another. But dig deeper, and you'll find that the division is not so clean. In general, relativity, space, and time are woven into the same fabric. Space-time and the directionality of one could influence the behavior of the other. You were familiar with the arrow of time, the idea that time flows in one direction from past to future. It's why eggs break but never unbreak, why memories form behind you but not ahead. This asymmetry is mysterious. The laws of physics at their core are time-symmetric. They don't care which way time flows. Equations work just as well forward or backward. So why do we only move one way? Some physicists believe the arrow of time arises from entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy increases over time. The universe began in a low entropy state, and it's been unraveling ever since. But why did it start so low? That question remains unanswered. Now imagine this. What if the arrow of time wasn't universal? What if certain regions of the cosmos flowed differently? Already we've seen strange behaviors near black holes and event horizons, where time stretches and stalls. We've imagined wormholes loops in space-time that could in theory allow travel backward. But here's where it gets weird. Some speculative models suggest that time's directionality could vary across vast distances. That the early universe may have contained time domains, regions where entropy flowed in reverse. If so, those ancient imprints might still echo today, warping the way galaxies drift, light bends, and structures align. In short, the universe's preferred direction might not be spatial at all. It might be temporal. Maybe what we're seeing isn't a slant in physical space, but a leak in the timeline, the fingerprints of a deeper flow we cannot yet comprehend. And here's a hypothesis that will haunt you if you let it. What if we're in the wrong half of the flow? A mirror version of our universe could exist identical in structure, but flowing in reverse. Its time arrow points toward our past. Its galaxies drift in the opposite direction. Its entropy unwinds. And between us a boundary, some ancient scar left over from the Big Bang. This is more than science fiction. It's called the Janus Universe Hypothesis, named after the two-faced Roman god who looks both forward and backward. Janus cosmology suggests the Big Bang wasn't a singular event in one direction, but a twin explosion, two universes born back-to-back each with time flowing away from the center. From that moment, both timelines expand outward, each believing they're heading forward. And, in a strange way, they both are. If true, then what we interpret as a preferred direction in the cosmos might simply be the legacy of that symmetry breaking a ripple at the interface where two timelines once touched. Does this idea solve the mystery? Not exactly. It introduces more questions than answers. Physicists still debate whether entropy is absolute or observer-dependent, whether quantum mechanics supports time symmetry at a fundamental level, whether wormholes could allow crossovers, whether we could ever detect our temporal twin, let alone communicate with it. But something about it rings poetic. The idea that direction isn't about where you're going, but when. That every photon, every galaxy, every cosmic whisper is just riding the tide of a universe remembering its own birth. Or, perhaps, anticipating it. And here's your final dark chuckle of the section. If time really does have a direction, and it's not the one you're following, you'll never know. Because your memories would work backward, too. You'd wake up before you sleep. You'd say goodbye before you meet. You'd float through a life that felt just as real, just as inevitable. So maybe direction isn't about forward or backward at all. Maybe it's about consistency, a shared illusion we all agree to dream together. And the universe. It plays along, mostly. You are now far from home, farther than anyone has ever been. Not in distance, but in understanding. You float silently deep within the framework of space-time, surrounded by galaxies that drift like sleeping embers. The question remains, why does the universe appear to move one way more than another? Why this great cosmic lean? And now another possibility surfaces, quiet, unsettling, and strangely elegant. What if the universe has a preferred direction? Because it's rotating. You blink. Space. Spinning. It's a notion so counter to our mental image of the cosmos that it seems absurd. Yet it's been proposed. In 1949, none other than Kurt Gödel, the logician famous for unraveling the limits of mathematical truth, offered a solution to Einstein's field equations of general relativity that described a rotating universe. His model is strange. It allows for closed time-like curves, meaning, in theory, you could leave your house, take a long detour through the cosmos, and return before you left. In Gödel's universe, the fabric of space-time isn't flat or expanding in simple lines. It twirls. And in that twirl, the past, present, and future lose their firm footing. Our universe clearly doesn't behave like Gödel's model. At least, not exactly. But could there still be a subtle spin, a global angular momentum too faint for us to easily detect? For decades, astronomers assumed the answer was no. Observations of the cosmic microwave background suggest an isotropic universe, same in every direction. And yet, patterns linger. Remember the axis of evil. That strange alignment in the CMB. It's been called a great cosmic dipole, an anomaly that persists across measurements, potentially indicating a large-scale preferred orientation. Some researchers have found hints of a rotational pattern in the spin direction of galaxies. More left-handed spirals in one half of the sky, more right-handed in the other. Coincidence. Measurement bias. Or the ghost of some ancient torque. If the universe is spinning even imperceptibly, that would naturally generate a preferred axis. Over billions of years, it could imprint a faint spiral onto the very structure of space. And here comes your metaphor. Imagine the universe as a vast vat of molten glass. In its infancy, it begins to turn barely, just a nudge, a drift. But as it expands, the spin stretches. Fibers elongate. patterns freeze. The galaxies you see now could be threads in that swirl relics of a motion too large for us to feel, but not too large to leave a signature. This theory doesn't violate relativity. Technically, a rotating universe is compatible with Einstein's equations. It's just inconvenient, because a rotating universe would demand asymmetry from the start, a strange kind of imperfection baked into the origin of everything. No neat symmetry, no pristine nothingness, just motion. What caused the spin, no one knows. Maybe it came from quantum fluctuations. Maybe it was always there. Or maybe it's an illusion, a trick of how we observe bound as we are to a single thread in a vast, tangled tapestry. And even if the universe isn't spinning, some theorists think we could be. Not just you personally, but the entire observable patch of reality. Some models of inflation, those violent moments just after the Big Bang, suggest that bubbles of space-time could form with internal rotational momentum. Tiny pocket universes with different rules, different constants, different axes. We might live in one such bubble. And our preferred direction, just a local quirk, like the swirl in a marble, or the eye in a storm. Here's the unsettling part. A rotating universe would likely collapse in the far future. Not from gravity, but from instability. Spin warps time, and too much warping eats away at causality. Things stop making sense. So if we are inside such a cosmic gyroscope, the clock is ticking not just forward, but in a spiral toward entropy. Of course, this remains speculative. The data isn't conclusive. The asymmetries are slight. Many argue that once you account for measurement error and cosmic variance, the spin vanishes. But still, it feels like something's off. As you continue drifting in silence, the sky above tilts slightly. Not literally, just perceptually. You start to imagine galaxies like dancers caught in a slow whirl, not orbiting a point, but spun outward from a hidden origin like sparks from a grinding wheel. And suddenly, the question, does the universe have a preferred direction, feels like it might not be philosophical. It might be kinematic. A physical spin. A rotation written across the stars. Or maybe you're just dizzy. One last dry chuckle for the road if the universe is spinning, and you're the only one who notices. Congratulations. You're now both a physicist and a heretic. Spin that how you like. You drift now toward the edge of understanding where speculation stretches thin and silence deepens. The universe may be rotating, or accelerating in a direction, or shaped by long-lost collisions. But beneath all these possibilities lies one final disquieting question. What if the asymmetry is us, not the Earth, or even the Milky Way, but consciousness itself, your act of noticing, perceiving, measuring? Could the cosmos seem directional because you are directional? At first, that feels like nonsense, but trace the thought carefully. In quantum mechanics, the observer changes the system. A particle behaves differently when it's being watched, not metaphorically, literally. The double-slit experiment, the wave function, collapsed the deep tension between determinism and probability. It all hinges on observation. So, what happens when the observer becomes cosmic in scale? You see, every map of the universe begins from a point, your point. Earth is at the center, not because of arrogance, but necessity. Telescopes measure from here. Satellites orbit here. Light arrives here, and redshift is interpreted from here. Every model, no matter how elegant, is built on a human reference frame. We assume the universe is isotropic and homogeneous, but only statistically, and only from our limited perspective. What if we're seeing a tilt because we ourselves are tilted? Your mind is not a neutral camera. It's a filter built on evolution and time and survival. It tends to see patterns especially where none exist. Pareidolia is not just for clouds and toast. It applies to galaxies too. There's a possibility that the preferred axis, the CMB dipole, even the galactic spin bias, they're all just reflections of our own measurement limits. Our instruments, our interpretations. It's not that the universe has a direction. It's that you do. You move forward through time. You remember the past, not the future. You feel a symmetry in your body, left brain, right brain, dominant hand, the curve of your DNA. Maybe that sense of direction leaks out into your cosmology. It's not an illusion. But it's not absolute either. It's a mirror. Still, the mystery remains. Some physicists whisper about cosmic consciousness, not in a mystical sense, but in a structural one. That awareness, observation, entanglement, all these quantum realities might scale upward. Perhaps the universe isn't directional. Perhaps you and the universe are entangled, pulling on one another, subtly shaping the map with every glance. A kind of participatory cosmos where each observer helps write the rules. It's fringe, sure. But the lines are blurring. After all, the best equations are symmetrical, but the world isn't. You wake up each morning with a past and a future, and you drift through space with intent. That's directional. And maybe, in the deepest sense, the universe simply reflects its inhabitants. But then again, some anomalies remain too crisp, too large, too statistically persistent. They resist full dismissal. Perhaps the truth lies between a universe with a subtle lean, filtered through a consciousness with its own asymmetries. Together, you and the cosmos are locked in a slow, silent dance. Not straight, not chaotic, just curved. A long arc bending through time and perception. And now, here you are, hovering at the edge of that arc, peering down its vanishing path, wondering if the curve was always there, or if you bent it simply by looking. The lights of galaxies dim. Time slows. The stars spin gently, and you exhale into the quiet. You drift backward now. Away from the center, away from the noise of spinning galaxies and asymmetric maps. The patterns fade softly like ripples in a deep lake. You imagine the universe not as a machine or a puzzle, but as a vast, quiet room. One with no corners, no ceiling, just silence and slow breath. In that silence, all the questions still remain. Why does light travel the way it does? Why do galaxies prefer one spin over another? Why does your mind sense a direction even in the void? But those questions no longer press down. They float beside you like dust in a sunbeam. There's a comfort in knowing that not everything has an answer, that the sky doesn't owe you symmetry, that perhaps you don't need the universe to be perfect only to be real. And so you exhale one more time. Deep, slow, final. The last photons from a dying quasar cross your mind like a lullaby. The stars above hold their silence. The galaxies drift without judgment. And you, small and curious and quietly spinning, settle into sleep.